You're welcome back once again. In this video, I'm going to take you through neighborhood of a point. This is a mathematical concept in calculus. So when you say neighborhood of a point, you first draw a row number line. A point here is representing a number, okay? So assuming I have any point B here, if I say the neighborhood of P, it means that I want to create an interval. Neighborhood means you are trying to create an interval around the larger population. So within this interval, I can create a small interval here around B from here to here. But what is the measure of my interval? I need something we call a radius. How far should I go from B to create my interval? So the radius is represented as delta, okay? On that note, in neighborhood, we are interested in finding what we call interval, okay? Interval. An interval has a lower bound and an upper bound, okay? A lower bound and an upper bound. That's an interval. So let's see something here. On the normal line, I'll have my lower bound to be A, I'll have my upper bound to be B. Within this interval, I have a center, okay? I have a center C. So once I get my center C, you realize that from A to C will be the same as what from C to the what B, because C is the center, and I'll call that the radius. Okay? So at this point, you realize that the radius on the left side here is equal to, but C is now the bigger because A approaching the negative side becomes smaller. So I get C minus A. This radius on the right side is equal to, now B is bigger, B minus C. Is that not it? Yes. So at this point, let's make A and B the subject. At this point, when I make A the subject, A will be equal to C minus what? Delta. When I make B the subject, I'll have B is equal to delta plus C. So meaning that in any situation, when I give you the center and I give you the radius, you should be able to give me an interval where the interval has an upper bound and a lower bound. So as I said, this is our center, this is our endpoint. Assuming that we don't know A, we don't know B, A will be giving us our C minus what? Our delta. And B will be giving us what? C plus or delta. So what I mean is, given a center and a radius, you should be able to find an interval, which we call the neighborhood around any point. And that point is what we call the center. So the goal of finding neighborhood is to create the interval by finding A and B as an interval. So therefore, I can say that my neighborhood, so I'll say that, let's say delta neighborhood, delta neighborhood, delta neighborhood of A. That is, I want to create an interval with a radius of what? Delta around A. Is generally giving us. Now I know that A is giving us what? C minus what? Our delta, right? So the C here was representing the center, but now I'm having my center as what? A, okay? I'm having my center as my what? A. You let me change it from A and let me make it something like P so that doesn't confuse you. So in general, if I want to find delta neighborhood of P, if I want to find a delta neighborhood of P, then I'll have the A here is always the center minus the radius. So I'll have my center P minus the radius what? Delta, comma. The next thing is what? The B. The B is our delta plus what? Our center. So P plus what? Delta. and this gives me my interval. So this becomes the neighborhood, delta neighborhood of what? P. That is all. Representing this graphically, you have your center to be P, and now you are moving to this side delta, this side delta. So what will be your endpoint? We are interested only in the endpoint, and that is all about neighborhood. Let's solve an example here. Example 1. Find two neighborhood of 0. Find two neighborhood of 0. How do we solve this? To find two neighborhood of 0, what you're supposed to do is locate your center, locate your radius. What is my center? I always tell you that the neighborhood of what follows is the center. So here becomes 0. The radius now is what? 2. Okay. So here is 2. So at this point, you know the formula. Always try and use the open. So here becomes my center minus my radius, comma, my center plus my radius. And that is going to give us negative 2, comma 2. That is all. That is all. Or if you represent this on the number line, you realize that here's your 0. Two neighborhood of 0 means that you're moving 2 units on the left, 2 units on the right, right? So you're going to have 2 units on the left. I'll have negative 1, negative 2. Is that not it? 2 units on my right, I'm going to have 1, then 2. So meaning that my endpoints will surely be what? Negative 2 and 2. And that is what we've got here using the mathematical formula. So it's the same thing. I was standing here and I moved. So where this is inclusive, this is inclusive. So the new neighborhood created is simply negative 2, negative 1, 0, 1, then what? 2. And you realize that this is a neighborhood around what? 0. We move twice on either side. And that is all about neighborhood. What we are going to talk about next is what we call deleted neighborhood. Deleted neighborhood. Neighborhood. When you say deleted neighborhood, this is almost the same as the normal or the delta neighborhood. So this is delta deleted neighborhood, right? So the reason why we use the word deleted here means we take away the center. We take away the center. So the center is not included. Okay. So if you have any interval and I find my delta neighborhood around, let's say A, right? When you say deleted neighborhood, it means that this A is not part of the interval. A is not part of the interval. So I want to find the interval around A by moving what? Delta units. But after finding that interval, I have to take A out of the interval because I have to delete it from the interval. That is the idea. So now let's see. Generally, neighborhood is giving us x minus A is the absolute of that. The absolute of x minus A is always less than what? My delta, where A is the center and delta here is the radius. Okay, so at this point they are saying that we should eliminate what? A, meaning that at the point A it becomes what? 0, right? So at the point A we are going to have what? X being what? A. Remember, at the point A we get x to be equal to A. For that reason I'm going to have A minus A is less than what? Delta. So it actually becomes what? 0. So what this means is that for deleted neighborhood, you're going to have 0 less than what? Here. So meaning that our expression here, x minus A, should be greater than 0 because we are deleting this out. So you know that whenever we put A into it, you should get 0. For that reason, we should delete it out by using an open end here. So this absolute now should be greater than 0 but less than what? Our delta. So the only reason why you get 0 in this manner is when our point is A, but we don't want A to be included. For that reason, our condition is saying that this expression should be greater than 0. So anything that will make this thing here 0 should be taken out. Okay, so at this point, it's the same thing as you have your center minus your delta, comma, center plus your delta. But after writing this, we state that our interval will not include what? So where x is not equal to what? C, right? So that is the deleted nature of it. So now let's see an example here. So an example, find deleted. So let's make it this way. Find 2 delta deleted neighborhood of 1. So the delta is actually the 2. So I was just putting in there for you to see. So find 2 deleted neighborhood of 1. This is the problem which you have to solve. 2 deleted neighborhood of 1. So how do I find 2 deleted neighborhood of 1? So as I said, this is the same as what you know. You simply locate your center. What is my center? Center is 1. My center, and this is my hot radius. You simply write your center minus your radius, comma, center plus what? Radius, right? So you're going to get 1 minus 2, comma, 1 plus 2. This is giving me negative 1, comma, 3. Then you state that where x is not equal to what? 1, your center. So your interval now becomes what? Negative 1, 0, 2, then 3, with the exception of 1. You take 1 out of your interval. So that is the concept of what? Deleted neighborhood. The concept of deleted neighborhood. So in summary, delta neighborhood is always giving us what? Delta neighborhood is giving us the absolute of x minus a is less than what? Delta, which implies the distance of a point within the center and any of the points is always less than the radius. Then for the deleted aspect, x minus a, the absolute should always be greater than 0 but less than delta. Thank you for being with me in this video. Please don't forget to like, you subscribe, and you also share.